So again, just want to say good evening and welcome to everybody. This is our review of Hurricane Lee, which was back on September 15th and 16th of 2023. And I'm Joe Deli Carpini, the Science and Operations Officer at the National Weather Service in Boston. And I will be taking you through a review of Hurricane Lee tonight. You can see a couple of images there, one of some rough surf and another of some tree damage over in Cohasset. So the overview, and I'm sure many of you remember Lee, really gave us a glancing blow as it tracked offshore, and it was always kind of predicted to do that, but it was a fairly sizable storm, so the impacts were really felt well away from the center. And for us, most of the impacts were on Cape Cod, the islands, portions of the Plymouth County coast as well. We pretty much saw wind gusts of 50 to 60 miles per hour. Really some very minor coastal flooding. That just wasn't much of an issue, fortunately. But what was more of an issue was really the hazardous marine travel. A number of ferry services were canceled for a couple of days. There was quite a bit of coastal erosion as well on Cape Cod and some of the eastern Massachusetts coastline, and very strong rip currents at some of the area beaches. And luckily, the storm was close enough, bringing clouds and rain and wind, that it really wasn't much of a beach day. But still, that's certainly always a danger. For us in the office, the tropical operations, things really kind of ramp up. The workload almost triples, believe it or not, because we kind of go into a whole different mode of operations. So as I mentioned, low staffing through the late summer. It was further stressed by a couple of events you might remember as well, and I'll talk about those pretty briefly. So significant flash flooding in Leominster, Massachusetts, and also a number of tornadoes. So we were kind of all hands on deck trying to get all of this covered. The forecast from the National Hurricane Center and even the models were fairly accurate several days in advance. And this really helped us kind of downplay the potential for some greater impacts. But what I'll talk about, and this is kind of important, there was still a lot of confusion among the media and even the public as to how to interpret the tropical forecasts. They are probabilistic. They're not what we call deterministic. So in other words, when we have a winter storm, we'll tell you how much snow, 2 to 4 inches of snow, but tell you, yeah, there's the potential for maybe 6 to 8. The tropical forecasts are all probabilistic. So they tell you what to prepare for to be safe, not necessarily what's going to happen. So one of the takeaways, and I'll talk about this, is we, in the Weather Service, think we need to do a little bit better job in communicating that when we talk about these tropical systems, because a lot of people just think everything is overhyped and it wasn't as bad as we said. And well, that's true, because we have that margin of safety built in as to what we tell people. So something for us to take back to the table for next year, certainly. So we'll start off. Here's a satellite loop, and it's about once every day. This is from September 3rd to the 16th. So if you remember, Lee really started off the coast of Africa as a tropical wave, and then eventually made its way across the Atlantic over several days. And you can see the storm there going through into the Bahamas and eventually off the East Coast and into Atlantic Canada. So it was around for quite a while. It took on that classic kind of buzzsaw shape that most of the hurricanes that track over the open Atlantic eventually show. And there were a couple of other systems out there as well. You can probably see, if you remember, September, early to mid-September was pretty active in the tropics. And then if I go to this other loop, this is a little bit closer to the time frame from September 11th to the 16th, and you can see Lee with that nice buzzsaw appearance coming up toward Atlantic Canada. And eventually you see it kind of loses its shape, and we'll talk about that too. That's what's called extratropical transition. Kind of loses that circular shape, and everything kind of gets front-loaded on the storm ahead of the center. So kind of glad this one remained offshore. It certainly would have been much more of a serious impact on New England if it had tracked a little bit closer to the coast. So on the surface, and this is a loop of all the surface maps during that time, you can see Hurricane Lee passed offshore. And when we talk about extratropical, for those of you who may not be familiar with that, it means that Lee transitioned from being a hurricane, which is a warm core storm. It actually has warmer air wrapped around its center because it originates in the tropics, to become more like a nor'easter. And a nor'easter is called a cold core storm. So this happens due to some pretty complex interactions with the polar jet stream as it reaches up this far north. And we actually have one of our webinars that talked about that a little bit, extratropical transition. So feel free to check that out on YouTube to find out a little bit more. But that's pretty typical of most tropical systems as they reach up here in New England this far north, especially later in the season when we have more of a stronger polar jet stream. So you see this transition. A lot of times the storm might be considered post-tropical, meaning it no longer has any tropical characteristics. But for impacts, we tend to keep those tropical storm warnings, tropical headlines kind of going on as to avoid some confusion. So again, extratropical, just going from a warm core to a cold core system. All right, so we'll talk a little bit about what happened, and really, overall, it wasn't too bad. We did have several reports of downed trees and some large branches, mainly for the coastal areas. So you see here Cohasset, West Yarmouth. That's really where a lot of the damage occurred. As you got a little bit farther inland, really wasn't much more than kind of a windy, late summer day. Really wasn't too bad at all. So minimal damage, which was certainly good news. And when we look at the winds, after a system, we always take a look at some of the top, sustained winds and gusts. This is what we came up with from various wind networks across the area. Remember, sustained wind for tropical storm force is 39 miles per hour or greater. So we hit that at a number of places: Eastham, Sagamore, Duxbury, Woods Hole, even Deer Island. So that actually verified the tropical storm warnings that were in place there. And as usual, we also start to see some stronger gusts too, and that's part of that extratropical transition that I talked about. So wind gusts, again, 50, 60 miles per hour. Woods Hole had 1 to 63, but for the most part, between about 50 and 60 miles per hour for the coastal areas. And then if we look at some of the buoys, again, tropical storm force winds, the buoy that's well southeast of Nantucket, one that is north of Provincetown, and fell a little bit short on Nantucket Sound and east of Boston and Massachusetts Bay, but still some pretty good wind gusts over the water as well, 40 to 60 miles per hour. And of course, you'd expect the seas to respond accordingly, and they certainly did. North of Cape Cod, seas 24 feet and 21 feet southeast of Nantucket. So, the offshore seas were more in the range of 20 to 30 feet, closer to the coast a little bit less, but still pretty decent, 6 feet in Nantucket Sound and 11 feet off of Boston Harbor and 15 feet in Mass Bay. So, certainly a respectable storm, on the order of a fairly decent nor'easter, I think, is in terms of impacts that we would see, aside from the snow. So the coastal flooding and erosion certainly was very limited, which was good news. Tides were not astronomically high, which was good. There was a little bit of surge, but really just minor splashover, minor coastal flooding. You can see this picture from Scituate, the waves splashing over the seawall. Sandwich, quite a bit of erosion, as you can see there. And this is one of the more vulnerable spots that we have along the coastline. So this is typically one of the spots we watch a little bit more closely when we get into our winter storms. Another area being up in Newburyport, Plum Island area. But you can see quite a bit of coastal erosion. So that was really kind of the main impacts from the battering waves. If we look at our tides, again, Nantucket is on the left. You can see really, there was no issue at all, over the past several days. Just, 4.4 feet, which is the beginning of this graph. And its Scituate is even a little bit below 11 feet. So really no issues there with surge. It really was the wave action on top that, gave us the erosion and some of the splashover. So fortunately, again, these tides astronomically, relatively low, which was good news. Higher tides, we probably would have had a little bit more of the way of widespread minor flooding, but this really never had the appearance of being a significant coastal flood event. As far as rainfall, again, not terribly too high either, and there was a fairly sharp cutoff once you got inland. Highest totals were on Cape Cod and the islands. Mashpee at a 1.14 inch total, which was the highest we can find, just shy of an inch on Nantucket, as well as in Orleans, and a little bit less in Yarmouth and Wellfleet, and really no significant flooding occurred at all, not even really any street flooding from these heavy rains. So that was certainly good news. But knowing it's been fairly wet since over the summer, the late summer, so it certainly would not have taken much more in the way of rain, maybe 2 to 3 inches to start causing some more serious issues. Okay, so let's talk a little bit about the forecasting side of it. So the origins of actually the forecast started September 1st. So the 7-day tropical weather outlook actually had this orange area painted out over the open Atlantic. And that was really the area that was that eventually ended up being Hurricane Lee. So, it was being monitored for, a decent chance of development over the next 7 days. And as we move up in time, September 3rd, you can see it shifted to a much higher risk as this wave actually formed off the coast of Africa. At the same time, we had two other systems, Gert and Katia, which both remained well offshore. But whenever you see this kind of track, especially, as in September, this always kind of gets our eyes open, in our office, certainly, because usually as these storms track toward the Leeward Islands, toward the Bahamas, that's usually ends up being something we have to kind of keep an eye on. So it certainly was in this case, but this is September 3rd. So we're a good 12, 13 days away from when the storm actually impacted our area. So we were watching this one, for quite a few days ahead of time. Okay, so this is a little complicated, but before we look at some of the model data, I want to just kind of show one of the things that we look at, and this is called ensemble sensitivity. We use this a lot with winter storms. It also works for these tropical storms as well. And what it does is it shows different kind of weather elements or different parts to the puzzle and how sensitive they are to kind of the ultimate forecast or the ultimate track. So this is about 84 hours to 120. So we figure, good 4 to 5 days ahead of time. And what this is showing is what would happen, what would we need to really bring this slower and farther west? Remember, the tracks and all the models, and I'll show it in a minute, were fairly much good agreement that it was going to be offshore. But there were a couple of outliers that brought it a little bit closer. So this slide kind of shows you what would have to happen for the storm, at least in the upper levels, for Lee to really track closer to New England and have more of an impact. So there was a few key features here, and I'll talk a little bit about them. First one, we always look out in the west. We want to see a ridge somewhere, almost in this position here. Notice it's a little bit farther to the west, but we want to see a ridge somewhere over the northern Rockies. The ridge is displaced a little bit farther to the west, so that means that's not a really good position to draw this toward the coast. But this deeper trough here, as it talks about merging, into Manitoba, would result in a stronger ridge downstream over the Great Lakes and northeast later in the time. That's this ridge right here. And that could eventually slow the system down and eventually even draw it a little bit farther northward. And that's because you would have higher heights to the north of Lee over this area along a departing trough. So we'll talk about that in a minute. But that would actually, these higher heights of that ridging would slow down its acceleration to the north-northeast and eventually steer Lee a little bit more towards the north and not so much offshore. And another piece is this trough. So remember we had a trough moving over us at this time. If this trough moved out quicker, that would allow the ridging to really become more dominant, and that would draw the storm closer to us. If this trough was a little bit slower to depart, it would easily kick it out. And that's kind of what ended up happening. This trough kind of steered it off to the north and northeast a little bit, just enough to keep it away from us. So, when we're looking 3, 4, 5 days out, these are kind of the things that we're looking at. We're not just looking at the model guidance verbatim. It's, okay, this is what, the model is telling us, but what are some other, possible solutions here? And, if we wanted to talk about what would it take to bring this storm farther to the north and west, well, it would take a deeper trough over the northern Rockies, building up a ridge over the east of the Great Lakes that would slow the system down and draw it farther to the north. So a lot of moving parts, we always say. This is certainly true with our winter storms as well. And that's why it's really tough beyond about 3 days or so to really lock in, the tracks of these storms. And you'll see that a lot over this upcoming winter too. It's just very difficult. There's so many different moving parts. The models are prone to, much higher levels of error at these time ranges. So that's why we always say there's a lot of uncertainty, beyond day 3, and we kind of just give the best guess at that point. But often these forecasts are certainly prone to further changes. Okay, so here is, and I'm sure many of you saw the model forecast. So these are the multi-model ensembles. This is several days out. So this is initialized on September 9th. And notice there's really, really good agreement as Lee goes into stays north of the Leeward Islands and north of the Bahamas too, and then makes a sharp curve to the north. Again, very good agreement that the storm would stay well off the coast of New England. But yeah, there's a little outlier there. I believe that was actually the European model at the time was drawing it right over southern New England, and later it ended up trending a little bit more to the east. So, there are outliers. They're not always wrong. So you kind of have to couch, your expectations, and, you can't completely rule out, a closer pass. But at this point, a majority of the guidance you could see fairly high odds that it would stay offshore. And that was certainly the trend as we got closer and closer in time. But so that's just to kind of show you why was there an outlier. Well, that probably goes to the previous slide I talked about. Some of those moving parts came together just perfectly enough to draw the system a little bit closer to us. So when we're forecasting, Lee, I'll show the Canadian model here. We weren't able to get some of the model data, but on the left is our 500 millibar ensemble. So this is kind of everything at that 18,000 foot level, and you can see what was going on. Here comes Lee. You've got the trough, which was hanging around just long enough to kind of kick it just to the east. Again, if this had departed quicker and this ridging here over the western Great Lakes had really taken over, then we certainly would have had more of an issue of it tracking closer to us. But you can see the trough that I talked about moving out of Manitoba certainly did sharpen, but this trough didn't really get out of the way in enough time to bring Lee closer to us. But so certainly, the Canadian was one of the models that was really onto it early on, did a very good job. But really, all of the ensembles, again, as I mentioned, really showed good agreement that Lee would track off the coast, or maybe even close to southern New England, a close pass, but that was about it. So, and you can even see in the Canadian ensemble here, the mean is well offshore. There's certainly quite a bit of spread. You can see some of the X's around there. But for the most part, it was going to be an offshore pass. And on here, these are the individual, what we call postage stamps. It's each individual ensemble member. So the Canadian ensemble is composed of 20 members, and I don't have them all shown here, but you can see 12 of them. And pretty much everyone has a pretty strong low somewhere either offshore or right near southern New England. You can see on all these panels. So that tells us, pretty high odds this thing was going to come close. There were really none that showed, a really far offshore pass with no impact. So again, as we go into the winter, if you want to look at some of the model data, looking at these, individual members, it's kind of a good way to go. Just kind of getting, an idea of what are the chances of us seeing something either close or directly impacting us by looking at these ensemble members. So it's really a good way to couch kind of what the individual model run is telling you, whether it's the GFS, the European, or the Canadian. So we use this quite a bit, and it's really, really helpful. Now, the forecast from the National Hurricane Center, did a great job. And just as a reminder, the cone that you see always represents historical error at different time ranges. So it's going to be smaller in the shorter term, and it gets larger as you go out in time. The storm will stay within the cone 2/3 of the time, but it can track outside 1/3 of the time at any given point. And as we saw with Lee, the impacts can occur well outside of the cone. So just because you're not in the cone doesn't mean you're going to escape kind of the worst of the storm. So I'll let this go through once again. And you can see, fairly consistent track. You don't see the track changing very much. The cone stays about, over the same areas, especially at that day 5, which is the last point. You see there's that curve to the north as we move on in time, and eventually it grazes Bermuda a little bit in the cone, but stays west of Bermuda. And then we eventually end up getting on the kind of the western side of that cone for a little bit more toward Cape Cod and the islands. And eventually, as we got closer in time, then it was mostly offshore, but just, again, a glancing blow, but enough to bring tropical storm conditions to parts of our coastline. Now, the one thing we do like to use with our emergency managers, and I recommend this for everybody as well, is looking at the probability of tropical storm force winds and the time of arrival. So what we tend to use, you can see on this as this goes through, the highest probabilities obviously remain well offshore, but they did graze the outer part of Cape Cod and Nantucket, which ended up being, what happened. Notice the timing on the most likely, it's fairly stable. In other words, it's not changing. It's pretty much Saturday morning, maybe Friday night at one point. But that tells us they had a pretty good handle on the timing of the storm. And as I mentioned, we brief these graphics routinely to emergency managers. We use not the most likely, but there's an earliest reasonable timing. Typically, it's about 12 hours before the times you see here. And that's what is used to advise when preparation should be complete. Again, allows a margin of safety. So in this case, I believe the earliest reasonable was roughly 8 p.m. Friday. So we were telling people, have your preparations done by sunset on Friday. This way you'll be ready when the storm arrives, when those tropical storm force arrive, winds arrive first thing Saturday morning. So again, I recommend looking at this in addition to the track and the cone. It shows you where the greatest chance of seeing those tropical storm force winds or even hurricane force winds would be. Again, we were on kind of on the 40-50% range initially, and then it did increase, over 90% as we got certainly closer in time. But this is good. This comes from a multi-model ensemble, not just one single model. It uses various models to come up with these probabilities, so works fairly well. So as far as our decision support, what did we do with that? Well, we began briefings for Lee on Monday, September 11th. Once we were kind of on the northern edge of the forecast cone, we knew at that point, we were going to be in it for a few days, and we wanted to kind of get the information out to emergency managers. So we began typically for when we have a tropical storm or hurricane, we start with these one-page briefings that you see here, and then we'll also begin our briefings to emergency management. So Monday afternoon or midday and afternoon, we began our briefings for emergency management at the state levels in Connecticut, Massachusetts, and Rhode Island, as well as the MBTA, the transportation system here in central and eastern Massachusetts. On Wednesday, we began briefings for FEMA Region 1. So FEMA's role is they handle kind of all of the support after the storm, getting funding, making sure supplies can get in where needed. So we coordinated with them, and we actually had a meteorologist deployed up to FEMA Region 1 up in Maynard, Massachusetts during Hurricane Lee, who could be on site to provide that information to them. And then on Thursday, we began briefings for the U.S. Coast Guard, Sector Boston. They are responsible for the waters off of Massachusetts. So we gave them some specific briefings as far as those marine impacts they talked about, the dangerous seas, the high winds, certainly keeping the mariners safe. So in addition to all of that, we also run a daily briefing for kind of our entire coverage area, Connecticut, Rhode Island, Massachusetts. So we run those in the afternoon as well, and those began on Wednesday. So in our operations, just to give you a little bit of a behind-the-scenes look at kind of what goes on, when we have a direct threat from a landfalling tropical storm or hurricane, so think about like an Henri or even an Irene, we typically go to 12-hour shifts where we have the day crew typically goes from about 7:30 in the morning to 7:30 in the evening, and then our night crew goes from 7:30 at night to 7:30 in the morning. It just allows for a better workflow when there's more of a direct threat. But in this case, we didn't really have that. So we didn't have to do our 12-hour shifts. We brought in an extra 2 to 3 people on our day shift for handling those briefings, the tropical operations, the media calls too. There's a lot more phone calls during the day, and one extra person on the mid shift, and yeah, that was me, to help with the tropical operations overnight. The phone load is much less during the overnight, so we really only need one extra person. We counted more than 50 media interviews also during the week, including several national and even international media outlets. Typically when there's some sort of storm affecting Boston, that gets the media buzzing a little bit, even in other parts of the world. We also had ongoing briefings for some scheduled events. There was one event in the city of Boston, so the Office of Emergency Management was receiving briefings for that. And the West Springfield Emergency Management Agency was dealing with the Big E, so we were providing daily briefings for that as well. Both of those were by email, but those were twice per day. But as I mentioned before, the flash flooding and the tornadoes stretched our staffing even more. Monday, we had the flash flood emergency for Leominster. There was also a considerable amount of flooding in North Attleboro. We had word of a possible dam break in East Grafton, which turned out not to be true, which was good. And Providence EMA, we were providing some additional briefings to them. There was ongoing flooding in the city that they were dealing with. And then on Wednesday, we ended up having 4 confirmed tornadoes. So there was quite a bit to do with that. So I'll talk about both of those here in a couple of slides. But in Leominster, you can see, I'm sure everyone remembers the headlines from that, just very disastrous. Flash flooding, we issued a flash flood emergency, which is a pretty rare thing for us to do. but up to 9 inches of rain fell in a very short time. Some of the other areas were also impacted, so we had to bring in extra staff just to deal with what we call the hydro ops, issuing the flash flood warnings, keeping up with what was going on, and talking to emergency management there as well. So we had a couple of extra people for that, in addition to the extra staff that we had to bring in to deal with Hurricane Lee. And then on Wednesday, surprise, surprise, we had 4 tornadoes. Short ones, but still we had to bring extra staff in first to handle severe weather operations. We had to monitor the radar, issue warnings, kind of keep tabs on what was going on. And then later we had to dispatch a team to survey the damage in all of these areas. So again, it was in the midst of the tropical operations, some of the recovery efforts we were helping with for Leominster, and everything else. So it was quite a busy week for our staff. But fortunately, we were able to send a couple of folks out. And this wasn't too far from the office either, which was fortunate. So they were able to get this done kind of in short order, but has to be done. We have to really make sure we get an accurate record of these tornadoes. So I'll finish here just talking about the messaging a little bit. And I'm hiding, obviously, the people who made the comments. But on the left, one of our media partners put out a tweet saying, this is one way to do a tropical storm warning, I guess. Where it says, plan for sustained wind should remain less than tropical storm force. Conditions will still be gusty. So that's kind of, what to expect. But again, when you plan for, a little bit more. So that's why the tropical storm warning is in effect. It's based on the low probability that there could be tropical storm force winds in that area. And then on the top, the couple of columns here, someone mentioning, the storm was overall so hyped, even for the areas it hit. One of the media partners said, I don't even show these warnings on the air or explain whether they're not legit. That's not really a good thing. So we're going to be working with them on that, with our media partners again. South Shore expecting much worse. So far, it's no big deal. Well, that's by the nature of what we do. And on the right, some other comments. I understand the need to be conservative in a forecast, but this doesn't make sense. A prime example of why false alarm ratings are higher than they should be. And there's just a lack of understanding here. So when we issue tropical headlines, they're probabilistic. They represent what people should prepare for, not necessarily what will happen. And I think that's kind of on us on the Weather Service to make that a little more clear, saying, it's likely that we won't see, strong tropical storm force winds. We did see them marginally, as I showed. But for a margin of safety, this is what you need to prepare for to be safe. And it's not so much of a big deal with a tropical storm, but okay, what if we have a landfalling hurricane coming in? Then, people really need to be paying attention. So, the way we message things, I don't think, again, the Weather Service does a clear enough job in mentioning that it's not necessarily what's going to happen. It's what could happen. So that's something we're going to have to work on with our emergency managers. And even as an agency, each winter we have a hurricane conference with the National Hurricane Center and other partners. So this always tends to be brought up, and we will certainly pass some feedback on that we got this year as to what we can do to do this a little bit better and message a little clearly. So I think if we told people that here's what you need to prepare for, we have a tropical storm warning because it's possible we could see this winds of X miles per hour, but really what you are going to expect will happen is this. So I think we really need to couch both, kind of like we do with winter weather. Here's what you can expect, but this is what you need to prepare for, and that's why there's a tropical storm warning. So I hope that makes sense, and that's something that we're going to certainly be working on this off season to be ready for next year, to really make sure people understand the difference between the tropical headlines and the other headlines, like our winter storm warnings and things like that. So this was at least it was a good example. It kind of brought this out on the open to us that we need to be doing a better job with that. So this was really the main takeaway for us from this event. So again, in summary, Lee gave a glancing blow to us, 50 to 60 mile per hour winds, some minor splash over, really more of an impact to the marine community, suspending travel for a couple of days. And that coastal erosion was also a big factor. As I mentioned, our tropical operations were really stressed further due to the significant flash flooding and the tornadoes. But the good thing was the models did a really good job, and that allowed the Hurricane Center forecast to be highly accurate several days in advance. It allowed us to downplay the potential for some greater impacts, but as I mentioned, our key takeaway is really the confusion among the media and the public is really how to interpret these tropical forecasts. So that's something we're going to certainly need to work on moving forward. So with that, that is our look at Hurricane Lee. I'm going to pause here and we'll take a look at some questions that came in through the chat. So give me 1 second and we'll go through everything. So let's see. Our first from Joe was on forecast a few days leading up to Lee. Had a few wild ensemble runs of the Euro and even the GFS with landfall in Southeast Mass. Yeah, that's correct. I know I showed the one Euro member that had gone, kind of over us. But yeah, after a while, it did stabilize a little bit, which was good. So, and yeah, very close call, similar to Carol 1953 into Western Nova Scotia. Yeah, I believe that was. So, luckily it stayed offshore. Let's see, from Ronald, interesting that the early predictions was for a much less active hurricane season due to El Nino increasing, yet we currently have 19 storms in our fourth most active hurricane season. Yeah, Ronald, if you saw the update that was in early August, it actually they increased the number. And that was the fact that El Nino was present, but the sea surface temperatures being so warm were expected to outweigh any of the influence from El Nino. So, the initial prediction were for relatively active, maybe not super active, but then those numbers were increased with the update in early August. So it does certainly turned out to be a pretty active season, absolutely. So it just goes to show you some of these long range forecasts. And Ronald also mentions interesting that 2023 was the second year in a row that a hurricane made landfall in Nova Scotia and the Canadian provinces. Yeah, that's right. Not something you see all the time. Let's see. Okay, without mentioning names, one weather service was saying they were the first ones to predict Lee to become a Category 5 and also the first to have a 7-day forecast cone. Hard to believe they were ahead of NHC. Yeah, I mean, there are certainly other companies out there doing the forecasts, and they're certainly, certainly open to do that. Some of it is advertising, as you all know, I'm sure, to draw in more clientele. But yeah, I mean, it's certainly possible they did. I don't know for sure, but yeah, I mean, that certainly can happen when other people are making their forecasts. So that's fine. Let me see. From Allie, had Lee actually made landfall in southern New England, either around the Cape or even maybe slightly west of Boston, what would the impacts would have been? Like what intensity would have had, or if it tracks to make those landfalls happen? Yeah, certainly would have been greater impact. If it went, to the west of Boston, that would have been certainly greater impacts for Cape Cod and the coastal areas. So remember, east of the track is where you get your wind and your storm surge. To the west, you have less wind and less storm surge, but heavy rain. So probably would have had more flooding, especially in those areas that were hit in central Massachusetts earlier in the week. I could see that certainly have been a huge issue. Probably would have had a lot more wind damage on the coastal areas. Probably a little bit more storm surge too. Could have resulted in a little bit more in the way of coastal flooding. Winds easily at that point could have been 70, 80 miles per hour. It was still transitioning, remember, to, as we call it, the extratropical storm. So it wouldn't have been a full-fledged hurricane or tropical storm at that point, but still capable of producing quite a bit of damage, especially since trees still had leaves on them and everything. So you would have seen far greater impacts. So that was kind of a good thing that it did stay offshore. Good question. Let me see. From Sebastian, did you guys utilize any of the new experimental European model machine learning products? They were just rolling out around the time that Lee got named and did a good job. Yeah, we were starting to look at some of that, Sebastian. That's fairly new. So, typically, the machine learning guidance is kind of the next frontier in weather forecasting. So you're going to see a lot of talk about that in the next 5 to 10 years. And it tends to do a pretty good job if it's trained properly, meaning it's trained with past events. So we did take a look at some of that. It's still very new, so we couldn't really put too much weight in that. But a lot of what we do when we get into tropical operations is it's really the National Hurricane Center's call with the cone and all the probabilities we base everything off of. We kind of tailor that track and probabilities to kind of our local area. So, but we certainly do look at it. We certainly talk to them about that. And I'm actually looking forward to next year and maybe even a little bit over the winter here, Sebastian, looking at some of that guidance, kind of see how it does. So I agree. It certainly picked up earlier than a lot of the other guidance. And let me see, from Sebastian, the ensemble sensitivity question here. Bit confused about what it was actually depicting after I read the tutorial that was provided. Okay, but the explanation kind of cleared it up. Yeah, it's think of it as a big what if. So what would have to happen for the storm to track closer to us? That's what really it does, and it shows the different pieces of the puzzle and kind of what has to happen to bring it closer. So again, it's something you can use with winter weather, and I encourage everyone. It's probably a little advanced, but it's certainly something you can look at. We look at it ourselves. Not everybody understands it at our office either, so don't feel bad. But it's certainly just kind of looking at, what would have to happen for this storm to come closer. That's pretty much, we're trying to answer that question. So good. I'm glad you're looking at it, Sebastian. Please keep it up. And he mentioned he also lives in North Attleboro, which was one of the hardest hit areas. Recorded 13 inches of rain within just a few days of time. Yeah, and I can't remember seeing that much rainfall in a short period of time. I do too. Yeah, we'd love to do a webinar. We wanted to do one on Leominster and even the tornadoes, but it's just been a time crunch with us, trying to keep our office running and everything. But if we have a chance, we'll certainly go back and take a look at it, and maybe we can get, maybe the end of the year webinar, we can put it as one of our events for the year. So stay tuned for that. From Tom, does a transitioning ENSO influence trough positioning, steering of Atlantic tropical cyclones? It can. So we'll have to see. It really comes down to kind of the weather in the next, in the days leading up to it. Not so much on the ENSO. ENSO is kind of a larger seasonal influence, not individual weather systems necessarily. So, I mean, it can, but it's kind of a little bit unknown as how that kind of is directly impacted. We're dealing with more transitory, troughs and ridges and things like that. Let's see, from Matthew, what do you think the pattern will look like for November? Ooh, good question. I think it's going to probably settle down a bit. We have quite a bit of warmth right now. We'll probably settle a little bit back to normal, but and I'll show you when we talk about our briefing, there's really nothing either way saying it's going to be warmer or colder than normal. So we'll get to that in the briefing, Matthew, but good question. We'll talk about November a little bit when we get to that. From Kevin, I know we've had a decent amount of rain. Has Eastern New England been down overall? I feel like a lot of heavier rain has been to the west. No, we've all been pretty much above average. Now, it has dried out in the past few weeks here, giving us kind of a breather. So we're a little bit down for the month of October, but not by much. But overall, our longer term trends are all very wet throughout the whole region. So as far as drought concerns, really none as we're going into the fall, which is good news. So we'll see how the pattern stays a little dry. Then we'll start to build up our deficits a little bit. But certainly, we're in pretty good shape here heading through the fall. Let's see, from Mark, if Lee traveled further west and made a direct hit, what previous storm could this have related to? Ooh, and how would the impacts differ from a typical tropical storm? Probably wouldn't be much different. I mean, I would say maybe more like the Henri or even the Irene with a little bit less rain would have had some strong winds. Again, probably over 60, 70 miles per hour in spots. I mean, gusts. There would have been probably quite a bit of tree damage to the east of the track. So, let's say it came in over Rhode Island and maybe northeast Mass, the coastal areas would have taken a good hit. There probably would have been, again, some flooding rains to the west since it has been so wet. So I would say, if you remember Henri, probably something close to that would be, I think, reasonable as far as a comparison. It was on a similar kind of, strength at that point. But it's always it's always the track comes down to the track. Where does it go? So in this case, it did stay offshore. And from our friend Eleanor. Hello, Eleanor. Thanks for the great info. You bet. Always good to hear from her. Eleanor has been retired from us for a few years, but glad she still stays in touch. And great to see you on the webinar tonight. Let's see, from Joe, a few runs of the halves. That's a new experimental model. Had Lee also around Boston with gusts to 130 miles per hour? Yeah, initially I think it did. But I think later on it did settle back kind of with the others. So yeah, some of the, it's an experimental model. Actually, the folks at URI are actually working on that with the Hurricane Center, which is cool. And it seems to have some promise, the halves model. So we'll see, going into next season. I'm curious to see how the verification did this year. We'll find out as that's done over the winter. So yeah, good point. And from Ronald, hard to believe that 2024 will be 33 years since Bob, our last hurricane. Yeah, the last major hurricane was Carol, and that's going to be 70 years. So yeah, there you go. So we are overdue. Let me see from Carlo. During the time leading up to the passive Lee, I noticed in your area forecast discussions, you were mostly just stating to check the NHC website. Is there any way that a bit more long-term description could have been provided on kind of the, let's see, on the, even if more on the conservative side? Yes and no. So the one thing we want to do, Carlo, is not confuse the message. So we want people to be looking at the National Hurricane Center forecasts. That's their area. That's their responsibility. We try not to put alternative scenarios in there because it can lead to some confusion or people maybe not believing the Hurricane Center forecast. So we do, collaborate with them on the forecasts. We do have input. So it is not just, them telling us what's going to happen. It's kind of everyone, working on the forecast together. So what you see from the Hurricane Center is actually the result of collaboration with a number of offices. It's not just them kind of on their own. We could put some alternative scenarios in there, but, it's something we typically don't do, with the tropical cyclones, just because we don't want to lead to that confusion. But, we certainly could make some maybe more general statements talking about some of those things I talked about in the sensitivity. We certainly could probably do that a little bit more, but it's dangerous if you start to stray too much from their forecast. So that's why we tend not to do too much with that, Carlo. Let's see, Joe was also looking at AI models. Oh, we're not great with Lee, with landfall over New York City and Western. Yeah, and Western Southern England. Again, the AI, it's how's the model trained? Is there enough, history going into that? It's not just, here you go and do it. It's got to have a database to kind of work off of and be trained from. So those are things that will certainly begin to improve in the next few years as more is done to those. From Ali again, how strong would it have been? Hard to say. It certainly was getting into some cooler waters, even though it was still a little bit unusually warm. But at that point, I think it would have been, at best, it would have held on as a tropical storm. I don't know, maybe, a Cat 1 hurricane marginally, it's possible. But there's a lot of ifs in there, and I couldn't say with any certainty what it really would have been if it struck us. But at least a high-end tropical storm, if not maybe a Category 1 hurricane by the time it was passing by. Again, from Mark, did you guys communicate with the Hurricane Center? Yeah, we did. As I mentioned, we do. So in the days leading up, we're talking to them. Usually, a few days ahead of time, we're setting up a game plan, with them. We're talking to them about, different things that have to be done as far as our tropical operations. So we are. We do, as you mentioned, we communicate with SPC sometimes, so we do with the Hurricane Center quite a bit. And actually, it's gotten a lot better in the past 3 years, I can tell you. We have our video chats. We're talking ahead of time as far as watches and warnings, and they certainly are very receptive to our feedback, which is great. So it's a much improved program over the past 3 to 5 years. It's not so much, used to be a lot of top down where the Hurricane Center would say this and we'd go along with it. But now they really ask for our input and our feedback on things. So it's really good to know. From Tom, was the ACE nominal for the number of storms? We'll talk about that. The ACE is the accumulated cyclone energy. And we're in a high era. I don't know exactly what the values are at this point. So I'd have to get back to you after the season. But yeah, we're in a high activity era. So that's part of the reason why, we're seeing so much activity, even in an El Nino year. So, and from Fred, yep, better to be safe than sorry. Warnings are important to be prepared. Absolutely. Thanks, Fred. All right.